Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Muhammad Suki. Matrix number DE220088. Okay, so this is for lab 1, exercise 1A, activity 1. So here is the circuit that I follow from the task. So uh, for the first value is we need resistance for 100 ohm. So we put the resistance value for 100. Then we run the simulation. So here is the voltage, 10, 10 voltage. And for here is 100. So the value for ampere is 100. And next is value resistance for 150. Okay. So we need to stop first before we change the value, and then we run the value. So this is the value for emitter 66.667. Okay, we to stop first, and then we put the value. Next value is 200. 200. Okay, then we run the simulation, and we got the ampere is 50. Okay, so the value is 50, and then we put first, then put the value is 300. 300. Okay, so we run the simulation, and the value for current is 53.33 milliampere. Okay, so next is for the last value is for 1000. This is the 1000. We run the simulation, and then we got 10 milliampere. Okay. I think that's all for exercise 1A, activity 1. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aib Adam bin Ahmad Ghairi. My matric number is DE220154. I am from group 3 from the section 2. So for this video, I will explain about the activity 2 for part A for experiment AC and DC measurement of resistor. So for the first part is DC measurement of resistance for the activity 2. So conduct the circuit and they have supply voltage supplies, emitter, voltmeter, and one resistance. So using MATLAB, I'm conduct the circuit for 20 seconds. So connect the and RA is set. So this emitter resistance. So set, and we can run the simulation. For the first value is 100 ohm. So this is first 100 ohms. So I will run the simulation so I can get the value of the current is 86.58 milliamp and the voltage is 10 volts. So for the next value is 150 ohms. So the value of the current is 60.42 milliamp and the current is save is 10 volt, 10 volt. So next uh, is 200 ohm. So I run the simulation, we can get the value of the current is 46.40 milliamp and voltage is 10 volts. So for the next value is 300. Run the simulation. So the value is of the current is 31.69 69 milliamp. So the voltage is same 10 volts. So next last value is 1000 ohm. So run the simulation. We can get the value of the current is 9.85 milliamp and the current also 10 volts and the volt is 10 volts. So for the calculated value is using the formula below is so you can get the value for the R1 is uh, RT for the 100 value is 115.5 and for the R1 100 ohms and the relative error is 15.5%. So for the 150 ohms RT is equal to 165.51 and for the R1 is 150.01 and the relative error for the 150 ohm is 10.33%. So next for the 200 ohms RT is equal to 200 with 15.52 ohm and for the R1 is 200.02 ohms and the relative error is 7.75%. For the 300 ohms RT is equal to 300 1.5.46 and for the R1 is equal to 299.69 and for the relative error is equal to 5.17%. For the last value of ohm is equal to 1000. So RT is equal to 1000 115 1015.2 ohms and for the R1 is equal to 999.7 ohms and the relative error of the 1000 ohms equal to 1.55%. So that's all from me for the activity 2 for the part A. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Akram Belhanda and my number metric is DE220112. For this lab one, I will take on part activity 3 on part A. So we need to do our simulation based on the sheet given, which is we need to the source, emitter, voltmeter, and resistor. So we need to set up the emitter with emitter internal resistance, which is 15.5 ohm for the emitter, and the voltmeter and the source. We using AC power. We need to find the current for this part. So, the circuit still the same. We need to change the resistor load R1 from 100 to 150 and 300. So the value given from this uh, simulation, we need to apply with the table content that given 1.3 current calculated at measurement value. After that, when we already find the value of the circuit current in the circuit, we need to calculate the I from circuit, I reading, I measurement, and the delivery. So for the resistance load 100 ohm for I from circuit, we use to the current ohms law. or Ohm's law formula, which is I equal to U over R. U is V 10 ohm, 10 volt if over to 100 ohm. So we get 100 milliampere. For I reading, we used to I equal to U1 over RL plus RA, which is RA is the resistance for ammeter. We find the value of current 86.6 milliampere. So this time we repeat for the resistance at 150 and 300 to find the answer. Then we need to find the relative error, which is the formula was given in the sheet. I1 circuit minus I1 measure. If over I1 circuit, uh, then we need to find RL for 100, 150, and 300. There we get the relative error for each of the resistance line. So that's all for me for this part. Thank you.
Right, for activity 4, part A, here is the circuit. The first one is the source here with 10 volt of voltage source and connected to the first multimeter here, which will be measure the current. Then we connect parallel with the second multimeter here, which will be measure the voltage, and also parallel with the load here, the last one, and the load value is 150 ohm. The load will be our manipulated variable because we will change the value to 300 ohm and 1 kilo ohm. So after we perform the circuit, we can run it, and from the data given here, we can conclude that we can get the result that our current is 67.667 milliampere here, and the voltage is 10 volt for 150 ohm. Then we stop and change the value of load to 300 ohms, and we run again. Then we will get the value of current is 34.333 milliampere for the first multimeter, and the second multimeter is we get is still the same, which is 10 volt. Then we stop the circuit and change the value of load to 1 kilo. We run again, and we get the new value of current, which is 11 milliampere, but the value of voltage is still the same, which is 10 volt. As we can see that when we change the value of resistor here, the value of load here are higher, the current result we get is smaller because the higher resistance it needs to be because the higher resistance that the current need to perform. That's for me. Thank you. Alright, for calculation activity 4, part A. First one is we calculate from the circuit by the given formula. PL equal to U square I in, U square in over RL. So for the first manipulated value, which is 150 ohm, we will get the answer is 0.67 volt. Then for the second value, which is 300 resistor ohm, we get the value is 0.33 volt. The last one is by using 1 kilo ohm, we get 0.1 volt. So for the second calculation, which is we calculate from the measurement by the given formula, which is PL equal to UL times with IL in the unit of watt. So the first one, for 150 ohm, we get 0.67 watt. For the second value, 300 ohm, we get 0.34 watt. For the last value, which is 1 kilo ohm, we get 0.11 watt. So the power loss of the wattmeter is 0.01 watt, and the relative error for the first manipulated value is 1.5%. For the second manipulated value is 3%, and for the last manipulated value is 9%. Just that for me. Thank you.